Hello everyone, my name is IRDINA and I will be presenting my infographic on case 3 that I choose. Ever wondered why tempered glass is so insanely strong, but can sometimes just spontaneously explode? Let's break down the engineering behind it using this case study on tempered soda lime silicate safety glass. First, the chemistry is an amorphous, non-crystalline material with a random atomic arrangement. We have CiO2 as network former, Na2O as the flux modifier, and CaO to stabilize it. This specific blend gives us high optical transparency and a safe fracture pattern, meaning when it breaks, it shatters into tiny blunt fragments instead of sharp, dangerous shards. But the real strength comes from the thermal tempering process. As shown in the stress mechanics section of this, we heat the glass uniformly to between 620 Celsius and 680 Celsius, which is right above its glass transition temperature but below its melting point. Then, we blast both sides simultaneously with a rapid air quench. Because the outer surfaces cool and solidify first, they become rigid. Meanwhile, the inner core stays hot and contracts as it cools down, trapping permanent residual stress inside. The golden rule of tempered glass engineering is surface compression must be greater than tensile strength. But things can go wrong. If you look at the diagnostics panel, poor cutting or grinding before tempering causes edge cracking and surface microcracks. And if your furnace heats or quenches unevenly, you get a residual stress imbalance, leading to an uneven strength distribution across the panel. But the ultimate villain here is spontaneous shattering. This happens because of microscopic nickel sulfide inclusion trapped inside the glass. Over time, these tiny particles undergo an alpha to beta transformation, expanding in volume until the glass literally explodes out of nowhere during service. So how do we fix it? We implement 5 strategic corrective proposals. First is edge finishing, fine grinding and chambering edge before heating to eliminate those microcracks. Second, optimize heating, keeping the furnace at a strict 650 Celsius with at least a 4-minute soak time. Third is quench control, which are calibrating blower pressures for a perfectly balanced airflow. Fourth is the heat soak test. To stop spontaneous shattering, we cook the glass at 290 degrees Celsius for over 2 hours in the factory, like furnaces. They intentionally forces those inclusion to expand and break defective panels before they reach a customer, complying with EN 141791 standards. 5 is quality control, which using polariscopes to check the stress distribution. The result is a 0 unexpected breakage, maximum strength, and a flawless service life. That's all from me. Thank you.